Good evening, everyone. And for the Zoom also, a warm welcome. I'm disappointed that there are not more people, but I trust there are quite some on Zoom because we also had interested parties phoning. For the records, everything is recorded. And if you want the presentation later, is it available? Yes. So you can either have the recording later or you can have the PowerPoint presentation if you write to us. There's a lot on in Windhoek, so it's not the topic that has people not come, but competition. We welcome Dr. George Leader. He comes from the States. He's been to WITS, like probably some of us. And we just blew his mind by showing him our stone tool collection. So I trust he comes again. And why he's interested in Namibian stone tools, human origins, etc., he will explain.
Thank you very much. Thank you, Valdi, and thank you everyone for coming out tonight. I understand there were some other things on and you chose this. So thank you. And to people at home on Zoom, thank you very much for joining. And yes, so my name is George Leader. I'm a professor at the College of New Jersey, and I also maintain a lab space at the University of Pennsylvania. And I've been working for about the past 15 years in South Africa on the earlier Stone Age. And we've at the request of the late Terry Hardecker, we were always trying to get some more work up in Namibia. The earlier Stone Age has been often overlooked in Namibia for a long time, or I shouldn't say overlooked, but there's much more to do on the earlier material. And a couple of years ago, one of my colleagues sent me a text message and he said, let's start thinking about that Namibia project a little bit more. And we started putting it together. And last year we had our first field season here. And then this year we just wrapped up our second field season. So I'm here to kind of tell you about those two, this project that we've now have ongoing and that we hope to continue visiting for the coming years, another few years yet to work on. There's still lots to do out there. So as I said, I apologize for some of my slides, but I imagine that I'm going to do similar talks when I get back to the States. So when I put on a map of Namibia, it's not for this audience, but it's for my audience to come. So let me use this. So here we are. As you know, we're in Windhoek, and what we're going to be talking about is a particular area in the Northern Sand Sea, an area that many of you are probably very familiar with and have been to, maybe spent time at Gobabeb, the research station out there. And that became a focus of our research for a few reasons. In the late 1970s, an archaeologist by the name of Myra Shackley went out and surveyed an area in the Sand Sea. I realize I advanced my computer, but I didn't advance this slide. So that'll get me a couple times, I'm sure. So she went out in the late 1970s and surveyed some sites out in the Sand Sea. As you know, it's a very difficult place to work, but there is a lot of archaeology on the interdunal surfaces, the gravel plains in between the dunes. That brings us to the reason why so much of the earliest material has been overlooked. Everywhere in Africa and quite frankly, everywhere in the world is in regards to lithic technology, surface collections are often overlooked. And that is for the simple fact that we as archaeologists have not been able to date them. And when, myself included, most of our work, when you think archaeology, you think pulling out a trowel and a brush, a paintbrush, and digging deep into the ground. And you get these layers, these stratigraphic units, where the oldest material is on the bottom, followed by younger, followed by youngest, and so on and so forth. That gives us a relative age of the change of technology. That's the easiest way to date something. With the invention of carbon dating and optically stimulated luminescence dating and cosmogenic nuclide dating, we were able to refine those dates even more, but it works much better in a deeply stratified site. So simply put, we cannot date surface sites very well. So we've ignored them for 150 years of archaeology. Now we need teams to take another look at the surface, because now we're starting to have the technology. Now we're starting to have the understanding of the geomorphic land movement processes that can deposit artifacts in a certain way. So that's our goal, to take a look at some of these. Primarily, as you can see on the screen, we're thinking about what hominids were making these stone tools. And I've put Homo erectus and Homo sapiens up there because most of the earlier Stone Age, the hand axes, the large cores, the cleavers, those tools, which I'll show you just now, are often associated with Homo ergaster or Homo erectus, somewhere in the ballpark of 500,000 years, all the way back to 2 million years in parts of Africa. Not so much on these sites, but much older than anatomically modern humans. The Middle Stone Age, which enters our record at about 300,000 years, but that date varies in different parts of Africa, is associated with modern humans, anatomically modern humans making very nice points and blades. You can see some of them on display right here. They're actually quite nice examples. So the sites that we're focused on right now are two in particular. And we took these two because they offered us a reasonably obtainable research question that could be answered. Namib IV and Narabeb. And importantly, Namib IV sits away from the ancient Sandab Flats. Okay, so that might give us a different perspective of what hominids were occupying this landscape. Narabeb, as you can see, these Sandab Flats here scar all the way out to the west, and at one point likely reached the coast, and would give us a different perspective of time-wise. So those are our two sites, and to get there, of course, we go out to Gobabeb and go south, and I'll get to that in just a minute. But I'll first focus on Namib IV, and the reason it caught my attention immediately was because in the 1970s, as I said, an archaeologist named Myra Shackley worked on this site, and she produced 3 papers on the site. Now, I don't want to speak, I never like to speak poorly about anybody who's not here to defend themselves. So I'll just say that I think in the last 40 years, archaeological techniques have changed, often improved, and methodologies have vastly changed. And there are just some inconsistencies in some of those old publications that really need another look. Namib IV is often cited in all of the literature on Namibian and South African too archaeology, classifying it as an Acheulean aged butchering site where Homo erectus came to butcher animals and take them away. That might be the case, but I'm not sure that it's demonstrated yet. The reason for that is because in her first publication, she discusses 394 artifacts collected from a 22,500 square meter area. That is a massive area, and it just doesn't make sense that there's only 394 artifacts. Since we've been there, that number doesn't add up. In her next paper, she discusses adding an additional 107 artifacts from a 1980 visit to the site. So now we're at 501 or so artifacts. And in a third paper about the site, she talks about 82 artifacts. So we're all over the place with what the collection looks like and what it contains. She also goes on to say that she believes it's a butchering site because she finds the fossil bones of Elephas rechi. Now, Elephas rechi, of course, is now an extinct elephant species that lived in the ballpark of 500 to 700,000 years ago, although that date itself has been changed to be much more recent as well. There were different species living into a much more recent period. But she doesn't say where the tools came from or where the fossils came from. So the fossils might be at one end of the pan and the tools might be at the other end of the pan. Okay, she does give us little hints, but there's just not enough information to make it very, very tight. So as you all know, this again, I apologize, is for my American audience because I'm sure many of you have seen or been to Gobabeb. We go out to the research station at Gobabeb where we take our final showers and we get a nice meal in us and sleep in a bed one last time. And then we head into the dunes, which is the fun part, right? So we go south about 10 kilometers up and over a number of dunes, and we get out to the site where we have to take all of our own water and everything. So it limits what we can do and how long we can stay out there. We stay for about 6 days at a time, tops, and then we go back to Gobabeb and get a shower and get a nice meal and sleep in a nice bed and then regenerate our energy and go back out to the dunes. If we didn't do that, I might have a mutiny from my team on my hands because while I can live for an extended period of time with sand in my ears, many of my colleagues, it seems to bother them. I don't know. We'll see how we deal with that in the future. But we get out here to Namib IV, and here it is. Here it is, a pan site. You can see that it's a great interdunal site, and it's quite large. So it is about at its widest, about 1 kilometer wide, and it's just about a little over 2 long. And that's a big site. That's a big area to cover. Now, the entire area is covered with stone tools. Now, if you'll remember, Myra Shackley said she recovered at one point 394 artifacts, then 501 artifacts, and then 82 artifacts. But we don't really know, other than at one point she says towards the southern end of the pan. Now, this is why it gets interesting, because where the tools come from means that we can get more information than just a surface site might allow us, right? Because remember, we can't date just a normal surface site. So why are we so interested in Namib IV as a surface site? Now, before I go into the details of our methods, I have to introduce my team. Okay, so my team consists of a few people from all around the world. I've got in the picture on the top right, to my standing to the right of me, we've got Dr. Rachel Bino from the University of Southampton. She is also an expert in lithic technology. Next to her behind the flag is Dr. Abby Stone from the University of Manchester. She is a specialist in luminescence dating and in particular has worked extensively in the dunes. Next to her is Miss Karina Ephraim from the National Museum of Namibia. She's the curator of archaeology there. She just finished her master's degree in public archaeology from the University of Pretoria, and we are trying to convince her that lithics is a great PhD project. And then next to her is Dr. Dominic Stratford from the University of Witwatersrand, who's an expert in deposits and site formation. Over here next to me is a member of a team from last year who unfortunately couldn't join us this year due to COVID. That is Dr. Ted Marks from the Center for Creative Arts in New Orleans. He is an expert in the Middle Stone Age and the Later Stone Age. So we have all these minds working on this problem of the surface, because it's no longer the correct thing to do to ignore the surface. So the first thing we do is we select on that entire pan a random area that we're going to sample the tools. And it has to be random because as soon as you pick where you're going to sample something, you introduce a bias into your research, as we all know, and we want to avoid that. We will talk about refining that in a minute, but the first thing we did is we picked a 50 by 50 meter area. And this was the last year that we took our sample, and we realized that there was no way in the short time that we were there last year that we were going to be able to cover this area, measuring every single stone tool on the surface. So ultimately, it got scrunched down to a 50 by 8 meter area. Now, from that, we collected data on 130 artifacts. Every single artifact in that area was very carefully picked up, measured, identified. All the measurements were taken. It was weighed. The raw material wasn't assessed. And then, importantly, it was put back in its place, right where it was found. This is an issue because, and again, our techniques have changed. Our understanding of what information we can get out of the surface has changed. 40 years ago, Dr. Shackley took a whole bunch of hand axes and collected them from an area and put them in a location in a row where she could take pictures of them. And that's fine 40 years ago, but now I don't know where spatially those hand axes were left originally, right? So when we go out to that site now, those hand axes are still sitting in perfect clusters lined up where she left them 40 years ago. Now, I don't think that she was carrying a load of hand axes 100 meters and placing them somewhere where she could take a picture of them. I'm sure they're all within a 20-meter radius of where she picked them up, but spatially, it's important for us to have that information. So here we are, we're collecting information on the hand axes now. And as you can see, these are not lined up here for me to study them. These are lined up here where they were left 40 years ago for a picture. And so what I would do is I would pick them up. I would take my data off of them, measurements and count scars and all the information that I can take out of that. And then, of course, photograph it, weigh it, and then put it back in its place. Even though it was still displaced originally, I still left them there. And so, I mean, most of you have seen hand axes like these, I'm sure, in either talks here or, you know, we opened one box in the collections here, and there was a stunning hand axe right in the top front. But these are associated with the earlier Stone Age. These are typically the earliest hand axes in Africa are made about 1.7, 1.8 million years ago. And they carry on. They are really the Swiss Army knife of the Paleolithic because they are the multi-tool all the way down to 300,000 years. At 300,000 years, we abandon the hand axes and we start making blades and points. I like to tell my students it's working smarter, not harder, right? We have these really efficient means of making sharp, small, effective hunting tools, cutting tools. We don't need these big lugging hand axes all around the place, right? So they go out of the archaeological record. Now, why does the placement of these matter? That is because we chose Namib IV for a particular reason. Namib IV, when seen at night, looks like this. And you can see here that this is at the end of the day. I may or may not have climbed the dune with my colleagues to share a warm beer. Yeah, I think we were sharing a warm beer at the end of the day. But as the sun sets behind it, you can see all of these shadows on the pan. From a satellite or from a photo in the day, or even to the untrained eye, the pan just looks like a flat piece of graveled land in between the dunes, featureless. But to the trained eye, you can see all of these different elevation points. And for our viewers at home, I'm looking in the middle of the picture, seeing all of the different shadows on that pan. Those are all deposits that are different from one another. Some of them are very much like gray, once clayey material. Some of them are very calcified deposits. Some of them are more reddish sands. And all of them have different ages. And what that's indicative of is different periods of wet, of river activity. So you have one river that cuts through and lays down a reddish sand, and maybe 100,000 years later, that river has dried up. Another river cuts through over 10,000 years and crosses that and lays down gravels or pebbles with gray sand. Now you have red underneath and a point where gray meets it. Your first bit of stratigraphy, as if you had dug down into the ground like a traditional archaeologist digging into the ground. We're looking for those connections on top. So moving forward, what we see with the artifacts is that the artifacts are in relation to these different deposits. When we look around, here we're at the southern end of the site again. When we walk around this site, the vast majority of the earlier Stone Age, the ESA deposits, are all coming off of these terraces. And the lowest deposits on this site all have MSA and very, very little earlier Stone Age. So without the complications of the other factors, that would really indicate to us that this level was a surface near water during the earlier Stone Age, maybe in the ballpark of 500,000 years ago. And the lower deposit was the surface where modern humans were sitting, maybe 100,000 years ago, making their stone tools 400,000 years after the earlier Stone Age hominids, right? So that's how we do it. And you can see that the other terraces behind the ESA point there, they're also of different elevations too. So it's our goal now to understand how these deposits can tell us dates and can tell us even a relative chronology of these artifacts. So just to show you a few of the really stunning artifacts out there, because they are quite unique. And Myra Shackley did a wonderful job of describing these artifacts. I hope to be able to add to that by giving some empirical data, some sizes for comparison to other sites around Africa. But we've got these very large rugby ball shaped cobbles in the Qseb River, and hominids probably in the ballpark of 500 or maybe even a million. We really don't know. Years ago, we're taking these rugby ball shaped cobbles and splitting a flake off of it lengthwise. I consider myself a pretty strong guy, as you can see. Thank you very much. I could not split those cobbles. And I have napped. I've been a stone tool napper for 15 plus years. And I do not know to this day how they were generating the force needed with another hammerstone to take that flake off, because it is a massive flake. Once they get that flake, the job is essentially done. Look at how nicely that's shaped. They took a couple more removals off of one side, but that big bit at the top is nice and flat, and it's a big, heavy flake, very good for chopping, maybe opening up a bone to extract the marrow. It's a very simple and expedient technique. They don't need much more refinement. We can pull a hand axe out of the collections here and it will be beautifully made with dozens of scars all around the side. That's not what they needed out here. For whatever reason, it was so simple. Here again, you can see another very simple. This is all on the right side, that flat grainy surface. That's all a smooth exterior, or what we call cortex, cortical surface of the cobble. This is the ventral surface, the interior, just a few extra removals and they're done. And there they have the meat cleaver. That's it. Very, very simple. Now, whether that means that they were only at this site for brief periods and it was an expedient visit, I don't know. I don't know if this is the technique of somebody who can't spend a long time out in this environment, because certainly that still was a harsh environment. Even if you have a river going through it, depending on the time, depending on the size of the river, we don't know if there were dunes on the sides or how far the river could support away from it vegetation and animal life. We just don't have those answers yet. So was it only along the river where hominids could traverse into this harsh environment, spend a short period of time there, and then they had to retreat back to the highlands or back to more vegetation? We do not know. But it's an expedited version of making stone tools. So how do we start to answer those questions? Then we do what archaeologists like to do, is dig holes. And this isn't the nice, sweet troweling and paintbrushing that you might associate with archaeologists. This is backbreaking with a spade digging, because we're not looking for artifacts. Now we're digging geotrenches. What that is to look at the deposits underneath. So we dug 6 geotrenches here in the red dots. You can see one right in the middle of the earlier Stone Age deposit. That one happened to go through about 40 centimeters of shale and almost broke my back. One in the dunes, which was equally as challenging, but only because that sand keeps falling in and falling in and falling in. And we dug some up at Fossil Bed 1, which I'll talk about in a minute, and some in the lowest portion of the site. And what we do with all of that when we get down is we look at this. These are the stratigraphic layers of geotrenches. And as I said before, on the surface, all of those deposits are different times from different alluvial activities and associated with tools in different ways. So what we do is we very carefully describe these. We look at what's in them. We look at the ancient root activity. Is there vegetation? Is there biological material? Are there pebbles? What color is it? Is it red sand? Is it calcretized? Rock hard calcrete is a nightmare to dig through, but it tells us all about how that formed. So what we do is we link those up and we say, oh, this red layer here is the same as this red layer here, and it's the same as the red layer on the top of that deposit on the other side of the pan. Right there, we're starting to piece together that sequence. That's evidence number 1. So, evidence number 2. We try to date it. And I don't mean date it like take it out to the bar and buy it a beer. I mean, we're going to try to get age. This is a tough crowd tonight. I'll tell you what, tough crowd. We need more drinks in the crowd, I think. We try to get optically stimulated luminescence dating. So that's Dr. Abby Stone there in the middle, and she's taking her auger and she's putting it into the ground. What she'll do is then jump in there and pull that auger out. We'll all shield it from sun, and she's got a special big black canvas that we put over everything, because as soon as it touches sunlight, it spoils the sample. So what she's measuring is the last time the particles in there were exposed to sunlight. That can give us an idea of when it was the surface level versus when it was buried. So if we can take one of these levels and say that there are artifacts in this red level here, and then Abby comes back and says that was laid down 150,000 years ago, then we have a match. Those tools were on the surface 150,000 years ago, giving them a minimum date. So that's what we hope to do with the optically stimulated luminescence. Now, there's another source of evidence that we need to consider. That's this fossil evidence. As you'll recall, Myra Shackley found Elephas recci, an extinct elephant species. That would suggest some sort of water, some sort of vegetation that could support large elephant out in the dunes. We do know that there were some elephants that were able to traverse some very arid environments. But I looked at fossil bed 1, and you'll see the arrow on the right pointing up to that corner. That is fossil bed 1. We went on our hands and knees looking across the top of fossil bed 1 for what looked like Elephas recci fossils. These fossils are very, very brittle. They're very white. They're very fragmented. And quite frankly, I don't know how you could get anything identifiable out of it. There are a few larger pieces that we might be able to identify as bovids, but frankly, I was really surprised, and I started thinking maybe she didn't have Elephas recci, because that fossil doesn't exist anywhere in the museum anymore. It's gone. It's disappeared. 40 years later, that's maybe on a mantle somewhere. We just don't know. But so I was thinking, my goodness, I really can't tell what's going on here. And I immediately said, well, maybe fossil bed 1 isn't associated with these stone tools at all, because we don't know the ages. So to say that this stone tool is here, these fossils are here, that means they were out here butchering Elephas recci. We don't even know if they're separated by 100,000 years. Maybe the Middle Stone Age. I do know of some unpublished potential OSL dates that make this much younger. So that fossil bed 1 might be more in the range of 30,000 years, which would make it kind of consistent with some of that Middle Stone Age technology, that younger technology. And of course, it also tells us that there were still pools of water in that area, drawing hominids and drawing game to that area, making it a landscape that was habitable. This year, however, our second field season, we started taking a walk, and last year we walked this entire pan, but we just didn't happen to get a good enough eye. But you'll see we found fossil bed number 2. Fossil bed number 2 has large, very different fossils. They're a different color. They are a really, really hard mineralized fossil that is definitely older or different in some way than fossil bed 1. So fossil bed 1 is perhaps very young, and I say young relative to archaeology, 30,000 years. Fossil bed 2 might be much older. Here we have what looks to be an extinct horse species. The teeth, and you still see part of the mandible where the teeth are in, and that will be identifiable. The occlusal surface on the top part of your tooth, actually can be identified for species. So we're really excited about the potential of this helping to date that particular deposit. We also have horse ankle in the top middle, and that tooth on the right looks like it might be the plated tooth of Elephas recci. We'll have to take another closer look at it once it's cleaned up, but we're thinking that this is the fossil bed that Myra Shackley was talking about in the late 70s. So is this associated with these deposits? It is at a very similar elevation. This year, we did not bring a total station with us. Total station is that tripod that you see archaeologists looking through and somebody at the other end with the prism. So we couldn't map the elevations to a pinpoint accuracy. We tried to do it on our GPS, but as you know, the resolution on a GPS just isn't good enough to get a great idea of those elevations. So we're going to be mapping this entire site and all of the deposits next year. So that is Namib IV, and I will quickly go on, and I'll make it quick because I know I'm running low on time. I'll quickly go on to Narabeb. So we moved southwest of Namib IV, out along the Sondeb Flats, and we get to Narabeb. And Myra Shackley, in her report on Narabeb, cites that there are earlier Stone Age tools, but she also gives a GPS point that lands us far away from this known Narabeb site in the middle of the dunes. So a lot of work needs to be done on which site she was discussing versus what site we're investigating. It is a very typical Middle Stone Age site. Flakes of mid on great cherts and a few quartzites. They are highly weathered. We took all of the measurements, left all of the flakes there. And it has gorgeous lavawa points, blades, cores. We could not find a hand axe, so like the earlier Stone Age material. We couldn't find it anywhere on that pan site. Whether or not that means it exists, I don't know. I think that pan looks pretty much like a Middle Stone Age site. The reason that we got Dr. Abby Stone involved was because she had already done some research out there, and it turns out that she had taken samples about 1.5 kilometers north of us, and she dated those samples, and I'll tell you that in just a minute. And we were very excited because if this turns out to be an MSA site, and it looks very much like it is, that means if we can associate her dates with our tools, which are in the same pan, but about 1.5 kilometers south, we have a dated MSA site potentially. That's very exciting, especially given that it's a surface site where we have for so long been ignoring. So we brought Abby Stone out again, and she took some new dating samples this year for us with the hopes of dating areas closer to us. Again, we looked at deposits in this system, and we're now over the next year going to have to put all of that data together. But it does look like that Narabeb might possibly be a Middle Stone Age site dated in the ballpark of 160,000 to 60,000 years. And if you're thinking, George, that's 100,000 years, well, you know what? You go do it. It's very difficult, and that's a pretty good condensed time frame for what we're able to do. Basically, what that tells us is that there was no dune on that spot in that time period, and that there was some water activity out there, and that's the minimum age kind of that early Homo sapiens were actually there producing stone tools. So it's got a great potential, and we're hoping to continue with that. There are other forms of evidence out there that I would like to continue to investigate. There are more root casts on the right here at Narabeb than I've ever seen on any other pan. And that tells us that, of course, there was a great deal of vegetation growing on this pan at one time. So that would indicate that there was a wet period. Some more dating and techniques have been conducted on calcification, on calcrete and calcified roots. And we're getting close to techniques that might be able to inform us about dates. On the left side, we've got a cobble that has been knapped. So that is an artifact, that is a core. And we're getting more and more interested in what we call desert varnish, micro laminations. So out there, many of the artifacts are just what we call sandblasted. The wind picks up sand and it hits them and it just smooths them out. You've all seen those very smooth rocks that are in the desert. And they get very polished very quickly, almost like taking sandpaper over them. But in addition to that, they grow microscopic laminations, sometimes magnesium, sometimes iron, in on the surface. And that happens when they draw minerals in from the air. And that growth might be reset each time you nap a flake off. So the exterior cortical surface should have a level of growth of this micro lamination. And then when you take a flake off of it, you're resetting everything. So if we can find an artifact where multiple series of flakes are taken off at different periods of time, sometimes that's visible in the coloration of the flake removals, we may be able to start piecing together how to use desert laminations, micro laminations, to date artifacts. So what does this all mean? Well, what can we say about hominids in the Sand Sea? I've just kind of said it. We don't know. Right? We started this project thinking that the Sand Sea was going to be a really nice case study. The oldest desert on Earth, many people think, 55 million years old, many people still hold on to. That may be the case, but was it always dry and uninhabitable? Well, probably not. These river systems broke through and moved through at different periods of time. That doesn't mean it was pleasant to live there, but like one river system and hominid groups following that river can transverse into harsh environments. But we have to do more work on, were they able to move through this landscape when it was dry, or only during these periods when it was wetter, during climatic fluctuations and or when the rivers were running there? So I don't have a great answer there on what, when they were there, but we are continuing to investigate it. But right now, what we can say is that there were early hominids at Namib IV during various periods of fluvial activity. Okay, all of those deposits were laid down by water somehow at some time. There's Middle Stone Age in the lowest parts, and that's important. Earlier Stone Age on some terraces, that's very important. And then the fossils allow us to really start piecing together the environment, but also what might be bringing the hominids out there. Was it a butchering site, as Myra Shackley said, or was it occupied for longer periods of time? And that's one of the questions that we hope to answer. What else do we have to do? We have to reassess Myra Shackley's collections. And not just her Namib IV collection, but there were many collections made of sites out in the Sand Sea that are sitting in boxes in the museum. Last year, I was able to look at 300 stone tools from Namib IV. Now, 300, that might not sound weird to you, but remember, at one point, Myra Shackley talks about 394 artifacts. Then in another paper, 501 artifacts. Then in another paper, 82 artifacts. So which is it? In the museum, unfortunately, there's 300. Now, over 40 years, things get moved, boxes get lost, misplaced, mislabeled. But for better or for worse, we have 300 artifacts. So I compared them to our original collection from Namib IV, and they actually compare relatively well. But it's the placement that matters. Our sample was random, so was hers, I believe. And now we need to go back and map those terraces and say what is on each terrace specifically. That will give us the biggest clues to when the hominids were there and exactly what they were doing. That's what we're going for. So we have 2 seasons of field work under our belts right now, and we will hopefully be back here for many years to come. We have been really, really warmly welcomed to Namibia. I've been just blown away by all the help and resources that we've been offered. And, you know, the earlier Stone Age, particularly on the surface, as I mentioned, has been ignored. but there's so much earlier Stone Age material in Namibia in general that has yet to be explored and analyzed. And I think part of the reason for that is there's so much Middle Stone Age, and there's so much Holocene material, and there's so much later Stone Age, and there's so much rock art, and there's so much historical archaeology that sometimes the earliest materials get kind of pushed to the side. And I hope that our team can continue to see what we can do about sort of discussing more of this earliest material in Namibia in the future. So with that, I want to say thank you to Valdi for having me, and thank you to the technical coordinator, Ruth, and to all of you here at the Namibia Scientific Society. It is been a great honor to speak to you all. I would be remiss if I didn't add that this type of research in the Sand Sea is just not possible without the support of the Gobabeb Namib Research Institute. Jillian and Eugene make it possible for scientists like myself to get into the dunes safely and be left there for periods of time to conduct our research. And our research is sponsored by a grant from the Leakey Foundation. And I don't know if anybody in here is from the National Commission on Research, Science, and Technology or the National Heritage Agency, but we were permitted under those two organizations. So thank you very much for permitting us. And thank you all very much for listening this evening. I appreciate it. And I will take any questions. And I've been asked to remind you to please speak into the microphone so that our Zoom friends can hear the questions.
Thank you. My first question is, when she came 40 years ago, or even longer than that ago, was her southern end the same coordinates than yours? Because the desert sand is changing the vicinity rapidly.
Yeah, it does. You know, new studies show that a lot of the dunes in this area, while the tops shift significantly, many of the bases are only shifting a few meters. Her maps show that the southern coordinates of where she was looking at are pretty much the exact same. Those dunes in that particular location have not moved significantly enough to cover up different materials.
Okay, thank you. And the other question I'm having is the artifacts.
Mm-hmm.
What material are they of?
Great question. I did not mention that. Yes.
Do they come from far, or are they made from stones in the vicinity?
Yes.
Thank you.
Great question. Most of the material is for the earlier material is coming from the Qseb River. We did some portable X-ray fluorescence, PXRF, and we kind of analyzed the elemental composition of those rocks and linked it back to the Qseb. So they're definitely bringing quartzite clasts from the Qseb. The Middle Stone Age is mostly on quartz. That quartz is probably also coming from the Qseb, but also there are some other sources where they're getting that up in the gravel plains as well.
Okay, one more.
Sorry.
Sure,
that's okay.
If they break these rocks, if you can call them that, they need a material that's harder than the one they want to break.
Yes.
So they need something more hard than the quartz.
Yes, typically quartzite on quartzite will work. So you can, as long as you can find a quartzite cobble, you can break quartz with it, and you can actually break quartzite with quartzite as well. The difference would be that the hammerstone will have to be smaller and rounder than the large cobble, rugby ball shaped cobble that's the base. I probably would guess that they are finding materials that have a natural fault in them and exploiting that imperfection to take off that largest flake. That's how I see them doing it. in a very intelligent, expedient method. Others have guessed that those are, they're sitting them in the sun for a long period of time, and that warmer stones are easier to fracture than cooler stones. All of that remains to be tested in a laboratory controlled setting. So yes, there's still so much to do there.
But that's very scientific, isn't it?
It is. And there are labs out there doing that. I myself have done a lot of controlled scientific, what we call experimental archaeology in the lab, all the way down to where we're eliminating nappers from sitting in a lab napping it, because nappers have a bias. So we have built these servo hydraulic press machines that bring 20,000 pounds of force at pinpoint accuracy and break rocks. So if you can think of anything more boring, it's tough, because we literally will put rocks into these machines and cut the rocks in certain ways that represent the same platforms that the hominids would have been napping. We then break the rock, and we can measure the exact amount of force that was needed to remove a flake. So we can actually now have an idea of the exact poundage that is needed to take a large flake off of a particular type of raw material.
Okay, another one.
Yes.
Not a question.
Sure.
This is just a small area of Namibia where you are busy. And thank you for that. But I think there are many more to be explored. I don't know whether you have been at Mesomkata or further north. There are many, many, many more sites.
I have not been further north.
Thank you.
We originally chose this location because we were interested in basically what it took for hominids to move into this hyper-arid environment. And we knew that it was going to be something to do with environmental fluctuations and available technologies. So that's why we started our focus here. Now, depending on how long we're working in Namibia, whether it's the next 5 years or whether it's the rest of my life, we would like, we could expand to other areas. Terry Hardecker, the late Terry Hardecker, worked down at Zebra River and did surface of the earlier Stone Age material all down there. There are some stratified deposits at different rivers in the north, where I understand that there are hand axes just kind of falling out of the sides of these ancient alluvial gravels. I would love to have a look at that, because now we have the availability of cosmogenic nuclide burial dating, and we can actually get dates on those. So, a long time ago, even river gravels were not something that archaeologists were particularly interested in. But in South Africa, we've really, I don't want to say perfected, but taken techniques to examine river gravels, really in a whole modernized way. So
Thanks.
you're very welcome.
For me, it's not really a question. All right, the question is that it's really very amazing, actually astonishing, that there's such a huge amount of these rock tools in that area. Being an arid area, not definitely any further than a highly vegetated area. So that is actually quite amazing.
It is. It really is. And, all of you are familiar with the first map that I put on there, but I'll just bring it back up there. Now in the last 2 field seasons, I've spent a lot of time in this region, and all of these pan sites are loaded with tools. GPS technology wasn't as good as it is today. Now it can be, within a few feet when you hit mark on your GPS. So Dr. Shackley's GPS coordinates are not as refined. So some of them land in the middle of dunes, and as you say, dunes do shift, but I'm not sure. Some of them are in the top of massive dunes that it would have taken a lot in 40 years to shift some of these. So I think it's a combination of the two factors. But I really think that one of the things that we hope to accomplish is actually taking a team out here to look at every single one of these pans and just be able to say what's there. Even if we can't necessarily do what we're doing at Namib IV to every single one of these pans, what we might see spatially is very interesting. Let's say that we get a cluster of earlier Stone Age stuff here, but not here. We get a cluster of Middle Stone Age material here, but not here. Why is that? And then all of a sudden you have a reversal. You have the artifacts starting to inform us about the environment, as opposed to the environment then informing us about who and what was there. So I think it would be very beneficial to put together a project like that. It's just going to take a really motivated, really lightweight, fast-moving team to get that done, because it will be quite a mission, as many of you know what it's like out there. Yes, please come on out. Yeah, that would be great. We do hope. We've been working with Karina Ephraim at the National Museum, who's been absolutely fantastic, and I'm trying to sneak her into like a lithic focus for her PhD. I'm not sure if she's going to bite on it or not, but UNAM is producing. Goodman is producing wonderful archaeologists, but I think that more. There's potentially much more we can do to raise the awareness of the lithic technology. And I hope to start to work with UNAM a little bit more and start bringing more students out and getting them involved and seeing what projects come from that, because there's lots of projects. I just saw another project that's about 3 rooms over that we could do. So, yeah. Yes. I'm nervous when the geologist picks up the microphone.
Yeah. Have you had anybody looking at pollen material in the,
No.
in the sediments?
No pollen, no phytoliths yet. We hope to. It just, sorry, I'm trying to stay. Should I stay in the no pollen, no phytoliths? We just have, right now we have limited funds, and we also just these past 2 seasons, despite all of that, are really still preliminary, right? So now we kind of know what's out there. We hadn't dug at all. We hadn't excavated at all last year. So this was our first time seeing below ground. Now there's potential to get somebody who does pollen, phytoliths. There's an expert in the UK who's doing marvelous things in Botswana on calcrete, David Nash. You might have come across his work. He expressed interest at a conference to me a couple months ago about coming out and taking a look. Maybe some more dating specialists, depending on if these dates work. There's potential to use other techniques. So we're gonna really hit this at all angles that we're able to.
Okay, thank you.
Sure.
The other question is, did you not find any potsherds or any
Nope.
pottery?
No pottery at
Nothing.
all. Nope. No pottery, no ostrich eggshell beads, no beads of any sort. Yeah. So these are much older terraces for sure.
Oh, that's interesting, because many years ago in the 70s, we actually had a little first trip to Sossusvlei, which was undisclosed or not open to tourism yet. And there I found potsherds in those Sossusvlei layers.
I have no doubt that there are more Holocene aged sites in the Sandsea itself, probably closer to the edges. But you get hunting blinds that you'll see at the edges and standing stones and a few stone circles and things like that, but not so much this deep into the Sandsea. So yeah, as of yet, none of the later material, no, not even there, we haven't even found any later Stone Age out there. So yeah, it's these were occupied long ago, a long time ago. Yes.
Thank you. I have two questions. One,
Okay.
because I have a wildlife background, I'm interested in this Elphus recce, which I know nothing about. What do we know about it? Maybe that can inform us about if we know something about its habitat requirements.
Yes.
What would be present at the same time of other hominids? The other thing is, the other question is about this luminescence dating, which I've never heard of before. Can you give us a brief
Sure.
introduction to that?
Sure. Yes. First question, Elephas recce. Yes. So years ago, our first knowledge of Elephas recce was that it was an extinct elephant species that looked much like modern elephants, but lived in the ballpark of 500 to 700,000 years ago in southern Africa. The building of, is it Zoo Park here in Windhoek? Zoo Park, they found a number of other Elephas recce in there. That actually changed what we knew about Elephas recce in southern Africa, that particular dig. They realized that one, there was much more variation in single species of Elephas and extinct Elephas than previously known. So they questioned whether or not we could divide those species as much as we had been. The second thing that they realized was that it extended the extinction, I should say, it extended the known time of the presence of Elephas recce. So rather than going extinct at 500,000 years ago, it was pushed down into the almost 100, I think 100, I have to, don't quote me on this, but I think it was like 100,000 years or something. So that changes how we can use Elephas recce to date things. But you're exactly right. When we have bovid, when we have extinct horse, equine, and when we have Elephas, that immediately says something about how much vegetation is needed and how much water is needed. And certainly those are places that hominids could also occupy as well. So that's great environmental data. The second question, luminescence dating. Every single thing on Earth gets radiation from the sun every day. When it is buried to a certain level, it is shielded from that radiation of the sun. As soon as it's buried at a certain depth, it starts to decay, like a half-life of the nuclear weapons that everybody's hiding, right? And that decay rate in certain particles is known. In quartz and quartzite, you have bits of aluminum, beryllium, things like that. And as they decay in their known rates, we can then date the last time it had been exposed to light. The same thing can be done using particles from space now as well. So not just from the sunlight itself, but from the cosmogenic particles that are hitting Earth at all times. Now they go much faster and much deeper into the ground before they come to a stop. So things that we date with cosmogenics must be much deeper in the ground, or you must be able to model how quickly they were buried. If they're buried at 1 meter, they're still getting some of those particles. If they're buried at 2 meters, they're still getting a little bit of those particles. If they're buried at 5 meters, they're mostly shielded from those particles. And then the half-life starts working. So then we can get that date of when they last sat on the surface. So those are the two of the techniques. Yeah, it's amazing. You know, I brought a colleague out a few years ago, and he was in South Africa, and he was figuring out the deposit rates and the cosmogenic particles. And he took a yellow legal tablet, and he started writing an equation on the top line, and that equation continued on the next line. And I was watching him and he filled up a page of a yellow legal tablet doing some Einstein crazy like equation that was mind-boggling to me. I mean, it is so far advanced. It's out of my league. I can describe it, and once they give me the results, that's wonderful. But they're pretty intelligent women and gentlemen. Yeah. Yes. Oh, it's right behind you. There you go.
Just a comment.
Sure.
Having just seen the most recent picture from the Space James
Yes,
Webb
yes.
telescope and seeing what's outside there, and this evening finding out what's down over there, I just find mind-boggling.
It is. It really is, isn't it? That we really have such a minute space in this whole universe. And when they tell me that each one of those dots on that new picture is a galaxy of 100 billion planets and stars, I can't wrap my head around that. They say that there are more planets and stars in the universe than grains of sand on all of Earth. Going out into the Namib, I don't know. I can't wrap my head around that. Yes, sir.
Thank you so much. The original material
Mhm.
where the artifacts were made from.
Yep.
Where are they from?
The raw materials.
The raw materials.
Yes, so in the earliest material, they're definitely getting it from along the QSEP. So they're going there. It's about 10 kilometers away. They're collecting the tools there. They're probably making some of them there. They're perhaps making some of them at the site itself. The site is, when we add up all of the tiny little pieces of debitage, what we call it. So when you nap a big flake, you're undoubtedly going to have little bits that fly off. We actually find all of those little bits at the site. So we know that they are making some of the stone tools at the site itself, rather than just making it somewhere else and bringing it there. The quartz, however, of the Middle Stone Age material, the younger material, I don't know where that's coming from. I'm sure that some of it is coming from the QSEB, but Middle Stone Age, anatomically modern humans, same as you and I and everybody in here, had much more probably knowledge of deeper, like larger areas of the landscape and where to go to collect. There are quartz veins that are exposed in the gravel plains. As a geologist, you might know where some are. I don't actually know, but there are a few exposures there where you can see lots of quartz coming out of the ground. They're probably taking that. Quite frankly, why they're choosing quartz, I don't know. I prefer to nap quartzite, but quartz fractures very badly. As you know, it fractures inconsistently and it's tough, but they're able to make very nice points and blades on that quartz. So they are skilled nappers. And but I don't know where that material is coming from. We will continue to try to work on that.
Thank you. So they are not directly, precisely identified. The
locations. The locations of the raw material, I can't say exactly like one spot, but if you go along the QSEB River, in the riverbed and along the edges, you'll find large areas where gravels have been laid down. There are some very old formations next to the QSEB, like the Oswater, and we don't know the ages of those terraces. They have some very large clasts in them as well, but I couldn't tell you one specific location on the QSEB. But yeah, if you go check it out, there's lots of raw material in there, and it's fun. It's fun to nap. So if you can take it, just don't leave all your flakes in the QSEB, because then I get confused when I see it. And
So I really think this scientist deserves a row of applause. Yeah.
Given it a short in your presentation, but what I wanted to ask is, why were you interested in this site?
Mhm.
And why my apologies, Namibian archaeologists like John Kinahan, have they been
Not working there?
Yes.
Well, so John, okay. So, yeah, we were interested in this site originally because we were interested in how it was possible for early hominids to actually occupy this hyper arid environment. You know, it's difficult enough to get in there now with a bucky and 100 liters of water and all the food you have, but 500,000 years ago or 700,000 years ago, it seems from the artifacts left there that they were quite simply able to transverse in there. But why? Was it like this when they did that? Or was it only during the periods when the rivers were running through? So that's why we started at these sites. Now, the second question, John, I've never met John personally. I hope to someday. I was actually hoping he might come here tonight, but I have the highest regard for John's work. I've read pretty much everything he's written, and his book last year was phenomenal. You know, John might just have his hands full with so many other sites in Namibia. I know that he's worked on so many different things. Yes, there you go. Yes. Yeah. So, you know, I've read a lot of his work revolves around the later Stone Age and the Holocene, which is, I think, his kind of specialty area. And so, you know, he's added so much to the Middle Stone Age record and to the earlier Stone Age record, but I know that he's got a lot on his plate at the moment, as you say. So we're hoping he will give us the nod of approval for how we've approached this site.
Otherwise you would have been here. And I want to make a proposal upon a suggestion of my colleague. When you said you need a very fast mobile team, we should think about involving civil society scientists like they do in the Cowdom. And you may not be aware, there's a project going on, full moon game count in the Cowdom, going on for several years now, August, September, October, the full moon. And people interested avail their services, get a fast training, and then they come up with the data. And one should maybe think about doing something like that. In the Namib, you get so many volunteers, people like me and you and whoever is interested, and you do a project.
Well, thank you for that kind offer, and I will definitely, now that I've met you all, I would be happy to keep the society in the know of what our plans are, and see how we can make that happen. And yeah, I think there's so much work to be done out there that we're always looking. I've never been a kind of closed door or very selfish scientist, maybe to a fault. But I always think that the more minds working on something, the better. And from all different disciplines and all different areas. We have these large goals of doing so much out there, but we also have anthropological goals of speaking with the Topnar that live along the QSEB and talking about their oral traditions of the Sand Sea, and showing them the stone tools and asking them if they have stories or what these are meaning to them. We have so much work to do, and would love to involve everybody. I would love to get UNAM more involved. Goodman has been wonderful, and I hope that we can build that relationship as well. But I'll definitely be back here because now I've seen the collections room.
So with that, I take it for granted that you notify us when you plan coming to Namibia.
I
You
sure
will
will.
certainly
I
give
sure
a
will.
few lectures.
I will be happy to.
because we get addicted to that kind of talk and we want to know more and more. I find it absolutely amazingly interesting.
Well,
And like when we do excursions, we go to some areas, as Amin said, we've not been far from that area where the furthest point of the Tsondap
mhm.
flats end with Dr. Roger Swart. And we have, as we went further, seen amazing plant fossil beds where certainly vegetation has been, and obviously then people and animals could have stayed there. So there's so much more. And as I said, we are all curious. I'm pretty sure next time this hall will be packed full because everyone is taking the message out there. Thank you so much
My pleasure.
for
Thank you.
this. And as I said, a row of applause.
Thank you.